All right, so this is still section 4.3, the second video in the lesson, and this video is going to talk about graphing the parent logarithm. So let's go meet the parent. And so the logarithm function, the logarithmic function, here's the name of the parent. Here's the equation of the parent. Notice that my base needs to be positive. It's not allowed to equal the number 1. And my x also has to be positive. So this is the name, the equation, and down here is going to be the graph. Now let's notice some important coordinates on our graph. I have those boxed in here. So one of those coordinates is 1, 0, because log base anything, log base a of 1 is always going to equal 0. And then the one underneath that, where I have the coordinate 2, 1, I like to call this base 1. Because in this case, notice that the parent that they're graphing is log base 2 of x. So this is base 1. And then for this one right here, this is going to be the reciprocal of the base, negative 1. So these are the three important points on the graph. When you look at this graph, the domain is going to be from 0 to infinity. The range will be from negative infinity to positive infinity. The y-axis is going to be the vertical asymptote, as long as x is approaching 0 from the right-hand side. And then the three main points that my graph passes through are going to be 1, 0, base 1, a is my base, a 1, and then the reciprocal of the base, negative 1. All right, now that's if my base is greater than 1. Notice here my base was 2 that we were drawing. So now let's take a look at when the base is between 0 and 1. Notice here that my base is a half. The important points that you notice, you have again that 1, 0 that I had on the last one. This one is going to be base 1. And this one's going to be the reciprocal of the base, negative 1. The y-axis here is a vertical asymptote as long as we are approaching, x is approaching 0 from the right side. And once again, the graph passes through those same coordinates on the last one, 1, 0, base 1, and the reciprocal of the base, negative 1. All right, so let's look at some characteristics. This is a repeat of what we just covered, but it puts it all in one nice, concise location. And so the first thing that we want to talk about are the important points on our graph. And so we have the point 1, 0, the point base 1, or A1, since A is our base. And then the other point is the reciprocal of the base, negative 1. Notice that when a is greater than 1, my function is increasing. When a is between 0 and 1, my function is decreasing. My vertical asymptote is going to occur on the y-axis. The domain is from 0 to infinity. The range is from negative infinity to positive infinity. All right, so let's take a look then at graphing some of these. So notice that this first one just simply says we have the log base 1/3 of x. So the very first thing that we're going to do here is draw our vertical asymptote. So this one is just one of the normal parents. So we're going to have a vertical asymptote along the y-axis. And then our important points are going to be 1, 0. We'll uncover these here. 1, 0, and then base 1. So this is going to be 1/3 1. Now you'll notice that the way I set this up, I went every 3 blocks to make up 1 unit. That helped with doing a 1/3. So 1/3 is right here. 1/3, the coordinate 1/3 1 is going to land right here. And then the third important point is going to be the reciprocal of the base, -1. So in this case, the reciprocal of the base is 3. And so we're going to go to the coordinate 3, -1. Now, before I graph this, I want to look at the overall shape. Notice that the bottom half of the graph looks like half a parabola turned on its side. And the top half of the graph is getting closer and closer and closer to that vertical asymptote. Okay, so then let's do the same thing here. The top side is going to be getting closer and closer and closer to my vertical asymptote. The bottom side looks like half of a parabola on its side. Letter B is also just one of our parents. There is no transformation here. And so we go ahead, we draw our vertical asymptote. We draw the first important point, which is at 1, 0. And then I like to draw the base 1, so that's going to be 5, 1. And then the other point that I'm not going to draw is the reciprocal of the base, so that's going to be 1/5, -1. And the reason that I'm not going to draw this one is it's pretty difficult to get 1/5. But here you'll notice that the top side of the graph is the side that looks like half of a parabola tipped on its side. And then the bottom half of the graph is the half that's getting closer and closer and closer to that vertical asymptote. Okay. Now on this one, you'll notice that I've already written the transformation. Due to what's on the inside, we are moving to the left too. And so we'll draw my vertical asymptote to the left 2. My special point is going to be at 0, 1. So imagine that your vertical asymptote is your new y-axis. So 0, 1 from there would land right here, which is at -1, 0. I'm sorry, I didn't mean 0, 1. I meant 1, 0. I apologize. Another important point on the graph would have been, on the parent graph, would have been 3, 1, base 1. If I were to draw the coordinate 3, 1, and then shift it to the left 2 units, I would land right here. So then the top side of the graph is going to be my half of a parabola on its side. The bottom half of the graph will be getting closer and closer to my vertical asymptote. I am asked for the domain and range. So the domain here, remember the parent domain was from 0 to infinity. This domain is from -2 to infinity. And the range is all real numbers. All right, for letter B, we want to shift everything up 2 units because of this guy right here. Now, when I take my vertical asymptote and I shift it up 2 units, it looks exactly the same as it did before. So this one isn't any different. If I take my special coordinate of 1, 0, and I shift it up 2 units, I'm going to end up moving the whole tick mark and everything. So up 2 units is going to land right here. If I take the original coordinate of base 1, which is going to be 4, 1, and shift it up 2 units, I'm going to land here. So this is at 2, this is at 3, so that new point landed at 4, 3. The top half of the graph is the one that looks like half of a parabola tipped over on its side. The bottom half of the graph is the one that's going to be getting closer to the vertical asymptote. Domain on this one is going to be from 0 to infinity, and the range from -infinity to +infinity. All right, we have one more, I believe. And so part C, the inside tells me to move to the right 3. The outside tells me to move up 2. Now, if my vertical asymptote just shifts up 2, it doesn't look any different. But the minute I move it to the right 3, my vertical asymptote is shifted to the right 3. So that's going to be drawn on the line x equals 3. So once again, if I draw my special points, so that first special point is 1, 0. If I take 1, 0 and I shift it to the right 3, 1, 2, 3, and up to 1, 2, I'm going to land on the coordinate, what is that, 4, 2. And then my second special coordinate would have been at base 1. So that's going to be at 2, 1. And if I take that guy and shift it to the right 1, 2, 3, and up 2 units, I'm going to land right here. So once again, the top half here is going to look like a parabola tipped over on its side, half of a parabola. And the bottom half is going to get closer and closer to that vertical asymptote. On this one, my domain is going to be from 3 to infinity. And my range will be all real numbers. All right, we'll stop that video there for now and proceed with the third video